Alright, so in this video I'm going to be making a tic-tac-toe game in Python that can be run from the command line. And this is for people who are maybe familiar with Python and have used it before, but it's not super advanced. But if you're brand new to Python, check out my other video, Intro to Python. So I'm going to start by adding this line here at the top, and this is going to tell Bash what interpreter to use when I run my file. So, I could use this Python command and then pass in my file here, and that works. But if I don't want to have to say Python at the beginning, I just want to call my file, I can do that if I put this line here at the top. And one thing to note that I actually did earlier is I ran this change mode command so that I could give my file read, write, and execute permissions, because for whatever reason it defaulted to not having execute permissions and I got a permission denied error. I tried to run this line here without the Python in front of it. But if I run that command before, it'll work. So that works. It doesn't do anything because I haven't written any code yet. So we're going to start by creating a grid. So I'm going to write a create grid method, and this grid is going to be represented as a two-dimensional array, meaning an array of arrays. So it'll basically be one array that has three arrays inside it, and each of those arrays will, have some three values inside each of them. And the reason this kind of makes sense is because if you look at it like this array actually works pretty well to represent this sort of 3x3 grid that we want to represent our tic-tac-toe board, where like this is the upper left corner, this is the middle, bottom right corner. It just kind of matches exactly the shape of the type of board that we want. So in order to do that, I'm going to start by saying grid is an empty array, for row in range 3, because that's how big our board is going to be. Row also equals an empty array, and then for column in range 3. And let's just append to row some like placeholder for an empty space on the board. And then outside of this loop, but inside the row loop, we will append to the grid that row. And then at the end of the function, we can return grid. So to see what's going on, let's also write a method to print our grid. And it'll take the grid as an argument. And this will just like display our grid in a nice way so we can kind of see what's going on. So we can just do this with print statements and this little f function that lets us sort of interpolate some variable value. And so I'm basically going to draw out what our grid looks like. And this code is not going to be very pretty. It's kind of ugly code, but it gets the job done. This isn't really anything fancy we're trying to do here. And let's put some like separators in here, and then we can copy this line, paste it a couple more times, change these to 1s, change these to 2s, copy this line. So now if we try to say grid equals create grid, and then we print that grid, let's see what happens. So looks a little funky. Let's add a few more of these. And that actually looks okay. So that's like an adequate representation of a board that we'd like to use. So now let's define a method that will let the player choose what symbol they want to be, either X or O. So we can call this ask for symbol, and we'll use this function in Python called input, and we'll print something like please choose either X or O as your symbol. Let's put this in double quotes so we can have those single quotes there. Cool. And so we can actually assign like symbol to this value, and this input function will print this out to the screen when we run it, and then it'll wait for the user to type something and press enter, and then whatever the user types will be stored in this variable here, symbol. And then we can return that. So if we call ask for symbol down here and then run it, we get this nice little output. And then someone can type X, and let's make this look a little better. You can type X and then it ends because it doesn't do anything else. And if we want to get a little fancier with this, we can create some sort of loop that verifies that what they've typed is either X or O, and if it isn't, it can just keep asking them for input. So a nice little way we can do this is actually define a new method inside this one called getSymbol, and we can just, we can actually just return this input. And then we can say symbol equals getSymbol, and while symbol not equal to x, and symbol not equal to O. What do we want to do? I guess we can just ask for symbol again, getSymbol, and actually we can just say symbol equals getSymbol. And outside this loop, we can just return symbol at the end of our function. So now, if I type something like it'll just ask me again, and I can keep typing gibberish. It'll keep asking me again until I type X or O. Cool. So now let's ask for another input, and this will be actually asking the player for what move they want to play. And this function will take that player's symbol and the grid. And we're actually going to follow a very similar structure to this function that we just created. We'll create a method inside it called getMove, and we'll return this input. Actually, we won't return the input. We'll define a variable called choice, and we'll say something like symbol's turn. Please choose a row, comma, column. And then the best way to do this is probably to have them input a row, comma, column, and then we can just split choice.split on comma, and this will create a little array called inputs. Also, I need to change that to a double. And now we can say row equals inputs 0, the first value of inputs, column equals inputs 1, and actually we'll cast these into ints because they're going to be taken in as strings from the command line. And then we can just return row, comma, column, the pair. And outside this function, we can say something like row column equals getMove, while grid row column does not equal space. And so the reason we're doing this is if a player chooses some spot that is already taken by some other symbol, that's not going to work. So we'll just want to ask them again. And so this is saying, like, if this spot in the grid is not an empty space, let's getMove again. And we'll set row column equal. And then at the very end of our function, we actually don't need to return anything. We can just update the grid at that row and column to be the symbol. So now if down here I did something like player move, and I'll need to make sure to print the grid again to see that update. Then if I run it, I'll ask for your symbol, and obviously I forgot. Well, let's just pass in X for now and our grid and see how this works. So if I choose like 1, 2, and whoops, so I forgot the grid. So let's try this one more time. 1, 2, and it works. So we have now successfully made a move. And for the purposes of this game, I'm actually going to have the second player be the computer. And so I'll define a method just for the computer's move. And this will take the computer's symbol and the grid. And the way we're going to do this is just generating random numbers. It's not going to be very smart. So we're going to need to, at the top of our file, import random, this random library, which will give us access to this function here, random.randint. You can say 0, 2. And again, we're going to follow this same paradigm that we've done up here, where we define a function to actually get the value, and then we'll sort of verify it in this loop and let them try again until they get it right. So we'll say row and column both equal randints between 0 and 2, and we'll call this our getMove function inside here. Let's indent these and return row column. So now we can say row column equals getMove while grid row column not equal to blank, we'll just ask again. say row column equals get move, and then at the end of the function we'll return row column. And you'll notice here the computer is taking, it has its own symbol, and the player has its symbol. And because the player is choosing their symbol at the beginning of the game, let's define a function called opposite symbol that will just take the player's symbol and return whatever the other one is, so that can be the computer's. So if symbol equals x, return O. This isn't a very fancy function, but it'll get the job done. Otherwise return x. Cool. So we've got some functionality now. We're just missing some of the logic of the actual game. In particular, we don't have any way of checking if someone has gotten to 3 in a row. So we're going to add some of those functions. But first, let's just test what happens here. And actually, let me stop this and let's put the computer move in here. And I shouldn't have hard-coded this x in here, because I already have this ask for symbol function. So let's say player symbol equals that. Let's put player symbol in here. And we can say computer symbol equals opposite symbol of player symbol. And then computer move is going to take computer symbol and grid. So let's try this out. Let's take x, 1, 2, and so we forgot to do something here. You may have noticed I'm returning row column here. Really, I want to be updating the grid to the symbol. So now, let's be O, let's say 2, 1, and cool, it works. So the computer moved basically instantly after I did. So let's think about some of the logic of determining 3 in a row. So we can do this with a few different functions. We can have a function for checking a row, checking a column, and checking diagonals. Each of these is a little different, but one function for checking all the rows is helpful. So let's start with that. So this will take some symbol and the grid and see if that symbol exists in all 3 spots of some row. This might make more sense as like check for row. And so I'm going to use a couple Boolean values here to do this. I'm going to start with something called any rows, which will start as false. Because we're going through for row in grid, we're going to go through each row. So I'll have some Boolean that indicates whether or not we have found a row with 3 in a row. And then I'm going to create another Boolean down here that will actually work in sort of the opposite way. It's going to start as true, and we're going to check until we see something that's not the symbol, and at that point we can set still valid to false. I think this sort of makes sense with the logic of checking if everything in the row is some symbol, because we can just assume that it is until we find something that is not that symbol, and then we know that that row is no longer still valid. So we can say for column in row, if column does not equal the symbol, still valid will equal false. And then after this inner loop, we'll say if still valid, any rows will equal true. And then down here, after our outer loop, we can return any rows. So we're going to go through each row in the grid. We're going to assume that that row is still valid. And as we check through each column, if the column's not the symbol, then we know the row is no longer valid. And then after checking all the columns, if it's still valid, then any rows will become true because we have found a row with 3 in a row. And then if that never happens, then any rows will still be false because we set it to false at the beginning. And so we'll return any rows at the end because it either will have been updated to true or it will stay false the whole time. So now I can try our check for column function. This will also take a symbol in the grid. And this one will be similar but slightly different. So we'll still use this any columns type of thing. But because columns are represented as like the values inside our inner arrays, just saying for something like for column in grid, that's not going to work because these actually won't be representing the columns. They'll still be representing the rows because this will be iterating through each array in grid, and each array, this, like this is our first array, this is our second array, this is our third array. And so the columns are really like the values in those arrays. So for this, we actually have to do something slightly different. For column in range 3, and we'll say still valid, it's true. And we'll say for row in grid, and then if row column does not equal symbol, still valid equals false. We'll still do this if still valid, any columns equals true, and then we'll return any columns. And so again, we have to structure this one slightly differently because this works nicely for how we set up our grid. We set it up so that it's a two-dimensional array, and like sort of the first dimension is the rows. So if we're just iterating through the grid, each of those values will represent the row. It'll be an array of three columns. And so for each of those rows, for each of those arrays of columns, then we can iterate through the columns. But here, we want our columns to be the outer loop, so we have to actually just iterate through the range of 3. And then when we go through our rows, we can key into the row at that index, this column in the range. And then our last checking function will be check for diagonal. And this one's a little trickier, but there is something kind of clever we can do, at least with the first diagonal. The diagonal that goes, from here to here to here is kind of nice because if you think about it, each of these indices has something kind of special about it. The row number and the column number are equal. This is 0, 0, this is 1, 1, and this is 2, 2. And those are the only squares in our grid that have that trait. So we can define this diagonal as the row index equals the column index. But the other diagonal is a little different. So we'll actually split these up. And we'll have a Boolean for the first diagonal. We'll say it's false. And we'll use a still valid, starting at true. And we'll say for I in range 3, if grid I, remember the squares in the grid where the index is the same. If that is not equal to the symbol, then still valid becomes false. And then outside this loop, we'll set the value of first diagonal to equal still valid. So now for the second diagonal, we can also do something kind of clever and look at another trait unique to this other diagonal. And that is that the indexes of the row and the column add up to the size of our grid, which is 3. It's a 3 by 3 grid. So this here is 0, 2. And sorry, when I say size, I don't mean 3. I mean the largest index, which is 2. So this is 0, 2. This is 1, 1. And this is 2, 0. So the thing that is unique to the squares in this diagonal is the fact that the indexes of the row and the column add up to 2. So we can say second diagonal equals false, set still valid back to true, and then say for I in range 3, and actually let's call this row, and actually let's call it row index, and then for column index in range 3. So for this, we'll just loop through all of the indexes in our grid, and we'll say if row index plus column index equals 2, then if grid, then it's a square that we want to check. So row index, column index, again, not equals symbol, then we can set still valid to false. And then after all this, we can return first diagonal or second diagonal. If we're checking for a diagonal, we just need one of those to be true. So if this is true, then it'll return true. If this is true, it'll return true. If they're both true, it'll still return true. Cool. So now we can actually put all of these together and define a 3 in a row method. And this will just sort of put these together. In row will equal check for row, in column will equal check for column, and in diagonal will equal check for diagonal. So this will be true if we have 3 in a row in a row. This will be true if we have 3 in a row in a column, and this will be true if we have 3 in a row in a diagonal. And then we just need one of those to be true, so we can just string them together with ORs, and that should do it. And so now we can also define a function that sees whether the game is over. And actually, I forgot something pretty important here. 3 in a row needs the symbol in the grid. Those are going to be passed into each of these functions. And similarly, this is over function will take the grid, and we can say something like if 3 in a row for x with the grid, or 3 in a row for O, the grid, return true, else return false. And we actually want something else in this is over function, and that is to check for a stalemate. When the grid is full but no one won, the game is actually over because there's nothing else anyone can do. So let's create another method called fullGrid that will check if the grid is full. And this is pretty simple. We can just go through the rows, oops, and in each row go through the columns, and if the column is our empty placeholder, then we know the game is not full, the grid is not full, so we can return false. If we've gone through all that and we haven't returned false, we can return true. Alright, so we're just about done. I'd like to clean this up a little bit, these at the bottom. This isn't really how we want to write a program. We'd like to have some sort of main function where we're actually sort of controlling part of our program, rather than just like putting these here at the top level at the end. So one convention is to say something like if underscore underscore name equals underscore underscore main, and then run some code down here. And we've got kind of the right idea here, but we actually want to add a while loop in here and say while not is over grid. And then we can keep these. And then after this while loop, we know the game has ended, but we can check like what the outcome was. So we can say if 3 in a row, player symbol, grid. We can print something like you win. Elif 3 in a row for the computer. Print something like you lost, maybe next time. Little hopeful message there. And then else, we can print something like stalemate because we know it's over but no one won. And then after all that, we can print something like thanks for playing. So let's see how this works. I probably have some errors in here that you may have noticed while I was typing it out. So let's test out our program. Please choose X row, X. Please choose row column 1, 2. Okay, let's try 0, 0. Okay, let's try 1, 0. All right, 0, 1, and you'll notice that the game should be over because there's 3 O's in this second diagonal here, but the game didn't actually recognize that, and that's because I have a little bug up here. In my check for diagonal function, I just forgot a line here. I just need to set second diagonal to equal still valid. And that should fix my problem. Basically, like, still valid didn't update, it stayed true. But second diagonal started false, and it didn't update to the still valid value of true. So there's actually another problem here, and that's that On the last move, if it's a stalemate, the game doesn't actually end. It just hits this sort of like weird state where it seems to continue to run. So what's happening here is I made my last move, got to this line, I made my move. It updated the grid, but it didn't get to this print grid statement yet, so we don't see that update. Instead, it got stuck on this computer move. And why did it do that? Well, I could add something here like while not is over grid, and that should fix my problem, because what it did is it said while this is not equal blank space, which is never actually true anymore because we filled up the board. So the computer can't find a correct move, so it's stuck in an infinite loop. So I need to add some kind of condition here. And there might be other places in my program that I could do some sort of check, like maybe I wouldn't even call the computer move function yet, but this should do the trick. So now if I try again, actually clear this. If I play again, let's choose O, say 2, 1, 1, 2, 0, 1, 0. I meant to say 0, 1. Oh. So it looks like actually I lost. So anyway, we have a working game now, kind of fun. It's not that fun, but it's cool that we made it. And hopefully this gave you some insight into how to make a small game. And it didn't take us that long. We learned some of the basics of Python, and you could take this even farther. There are also plenty of improvements I could make here, or some refactoring. For example, I could say something like describe some constant up here, like size, and maybe symbols, in case maybe I want them to be easier to change. I can refer to them in some of the other places down here. And in theory, this actually could allow me to create a grid as big as I want. Unfortunately, that's a little hard with the way this print grid function works, but it is possible. And here I can do something like symbols 0, return symbols 1, else return symbol 0. Make this size, size, size. Anyway, I guess this could be size minus 1. I think that will remain true the larger the board gets. And then this could also be improved. And actually there is one more thing I want to add here. Let's put this full grid function inside our is over. Because if the grid is full, then our game is over. And here we can do something like loop through our symbols. And this will just be basically the same code. And so these are more like stylistic improvements. They might help a little bit with things like scaling your program to do bigger, more interesting things. And we'll put that outside the loop. But anyway, this is a reasonably nice looking program. Things are broken nicely into functions that aren't very large, that each sort of do one thing, which is a good stylistic practice in programming. And this is only it's less than 150 lines of code. We've got our nice little main function here, and it's a pretty simple program, but it's a nice way to learn some of the basics. Anyway, I hope you enjoyed this video. If you did and you want to see more content like it, please feel free to like and subscribe. I'll also be posting some source code like this on GitHub, where you can go and look at my source code if you want to see exactly what I've done. In case it's a little hard to follow along in the video or you just want to see something for reference, and I will put a link to that in the description. Thanks for watching.